Hello guys, my name is Ismail Kamal, and today I will be recording a video of me explaining plots and tables for this Xfoil project. So for this project we got three parts. Okay, for part one, I'm gonna start explaining how I got my lift coefficient versus alpha, angle of attack, and drag coefficient versus alpha, and then my CL over CD, which is the aerodynamic performance against alpha. So for the first part, we got three airfoils: NACA 0015, which is a symmetric airfoil. The second one is a cambered airfoil, NACA 2415. And for the last one is the Clark W airfoil that we got from the database. So I'm just gonna go to my airfoil data website, and then I'm going to be showing the link of the airfoil that I downloaded online. So this is the one I got, Clark W dot. So after I download this, I had to change it in Excel, and then I can show you guys how I printed it. So I'm just gonna close my Xfoil software here, and I'm gonna start this project by showing you the first part. Okay. All right, so for the first part, we got a NACA 0015. So I'm just gonna show you guys the process of how I got the graphs for this airfoil, this symmetric airfoil. So first I type NACA, and then the software asked me about the 4 or 5 digit airfoil designation. So for this one is a symmetric airfoil. That means the first two digits gonna be 0, and then I can just go ahead by typing PPRAR, and that can show you my airfoil. So a couple of things I'm gonna change, and that's gonna be my N, number of panel nodes. So I'm gonna change it from 160 to 250, and then my T, which is my density ratio, I'm gonna change that to 1. So after I hit enter, we can see the current airfoil with the new number of nodes and the density ratio. So now we can go ahead and find our plots. So I'm gonna type operate, and then I'm gonna change this to a viscous. Since it's already an envision, I'm gonna change it to viscous flow. The Reynolds number that they were asking us for is 1 million, so it's 6 zeros over here, and then I'm gonna change my iteration number from 10 to 1000, maybe. Yeah, I can just do 1000. That's what I did for all of them. And then now I'm gonna show you guys the plot for our angle of attack from -5 to 15 with an increment of 1. So after I do that, we can just look at our airfoil with all the data that we need. There's a thing that we need to do here so we can save our file, which is PACC. Here we can just save it, and I can call this file NACA 0015. Okay, so I saved it. I'm gonna click yes on this. So after I save my file, I can just go here and show you. I can go to my Excel, and I can show you I can open that document that I just saved. So I go to my class, and I'm gonna go and open this NACA 015 here, fixed width, next, finish. So I already have all my tables and stuff saved here. So after I save the file, I can just open it using Excel, and then I can show you straight here my data for NACA 0015. So these are the results that I got, and then I had to go and plot them in Excel. So after I plotted them, I had three graphs, three plots. The first one is CL versus alpha. So I took the x-axis to be my angle of attack, and I used degree for this one. For my second one, I can just go ahead here and show you my NACA 2415. So I have that NACA 2415 and orange. So the blue one is the symmetric airfoil, and we can see the difference between the cambered airfoil and the symmetric airfoil. So we can see the cambered airfoil is gonna be is not going to be crossing my origin here. So it's crossing point something and 0 degrees. So alpha equals 0. My CL, my lift coefficient, is not equal to 0 for my cambered airfoil. And for the last airfoil, I'm just gonna go ahead and show you how we can load it. So this is my Clark. So after I downloaded from the UI, you see the airfoil data website. I changed a little bit in my my file in Excel, and then I saved it as a notepad, as a text file, and then I can go ahead to my Xfoil software, and then I can load that file. So I called my file Clark W and then dot. So after I loaded my file, I can do the third part of my first part, which is case one, which is get the plots for a Clark W airfoil that I got from the database that I have. So after I loaded my airfoil, I'm gonna go and quit first, and then I'm gonna show you. So load Clark W dot. This is my airfoil. I'm gonna show it here. Change the number of nodes to 50. Thickness ratio to 1. I hit enter again, and we can see it. And then I'm gonna be going to operate. I'm gonna change it to a viscous flow. The Reynolds number of 1 million. And then change the number of iteration to 1000. And now I can just look at my angle of attack from -5 to 15 degrees and an increment of 1. So this is it. Okay. This is my airfoil, my Clark airfoil. After I save it in my Xfoil, I can just go and find these things that I got from Excel, my CL, CD, and CL over CD versus alpha. So this is my Clark one. It's going to be the gray one. We can see that the Clark airfoil is a little bit more cambered than NACA 2415 and NACA 0015. We can also see that it's more the minimum CD for the Clark W airfoil is a little bit higher than the two other airfoils that I got. And we can see the difference in our CL over CD versus alpha. So these are the results that I got for this Clark W airfoil using Excel, of course. I got them somewhere over here, right? And now we're gonna be going ahead and showing part 2 in a different video, I guess. Thank you.